name's Anil Nair, and I'm an aerospace engineering student here at UCLA. And I'm going to help you by going over some math concepts and examples. Good luck.
This is the example video for optimization. So we're going to find, for the first example, the largest possible area of a right triangle whose hypotenuse is 4 centimeters long. So we know area in terms of triangle's base and height is 1/2 the base times the height. So let's draw a picture of the triangle. A right triangle with a base b and a height h, and we know the hypotenuse is 4 centimeters long. By the Pythagorean theorem, we know that h squared plus b squared equals 4 squared, which is 16. So if we solve for e, we get that b equals 16 minus h squared, square rooted. So now we can plug this into our area to get area in terms of just the height. So area is 1/2 h times the square root of 16 minus h squared. If we take the derivative of this with respect to h, we get 1/2, and we do the particle, so h times 1/2, 16 minus h squared to the negative 1/2, plus 1 times 16 minus h squared, square rooted. Setting this equal to 0, we get, we lose the 1/2, and we get 1/2 h over square root of 16 minus h squared, and we get plus 16 minus h squared, square rooted. So, and sorry, I forgot to do the chain rule here. There should be a negative 2h here. So this negative 2h should be right here. So this should be negative 2h squared. This 2 will cancel with that. And we get 0 equals negative h squared over square root of 16 minus h squared plus square root of 16 minus h squared. If we subtract or add this over, we get h squared times square root of 16 minus h squared equals square root of 16 minus h squared. Multiply both sides by square root of 16 minus h squared, we get h squared equals 16 minus h squared, which gives us 2h squared equals 16, which gives us h squared equals 8, so h has to be the square root of 8. And we know that this doesn't minimize the area because we could get negative values for the area with this function. So we know that this should be a local max for the area. We plug this back into this base formula. Base is 16, or square root of 16 minus h squared, with h being square root of 8, so square root of h squared is 16 minus 8 square rooted for the base. The base ends up also being square root of 8. So base equals the height, which equals square root of 8 centimeters.